Hello again, Trig. We are going to be working on matrix row operations this week. So this is continuing from last week, week 2. This is going to be our Q4 week 3. So if you think back to last week and the last example we did, we had a system of equations that looked like this. X minus 2y plus z equals 7. 3x minus 5y plus z equals 14, and 2x minus 2y minus z equals 3. And last week we used Gaussian elimination to turn this into triangular form. If you think about what we were doing, really, the entire process was just working with operations on the coefficients of each of these variables. So this is where matrices are going to come in handy and help us out. So an augmented matrix is what we are going to write next. So augmented is more than just a regular matrix. It usually means there's like the coefficients plus your constants on the other side of the equal sign. So if I take this system of equations and I just take the coefficients out, I can write this pretty easily as an augmented matrix. So starting with that first equation, that's going to be my first row. 1, negative 2, 1, 7. My second equation is going to be my second row. 3, negative 5, 1, 14. Third equation, third row. 2, negative 2, negative 1, 3. Let's put our brackets around it to indicate that it's a matrix. And with augmented matrices, not always, but often you will see people will draw a vertical bar right here to indicate where the equal sign is. Now, really, when we're doing like the Gaussian elimination, we don't need this part so much. We really just need to worry about this stuff over here. So you'll often see people using just the left-hand side, but it gets a little sticky. So we're going to use the entire augmented matrix today and talk about a couple of things. So we talked last week about triangular form. For a system of equations, well, we have a equivalent version of a matrix, and that's called row echelon form. So how do we know if an augmented matrix is in row echelon form? Well, there's a couple of things that we need to look at. So let's get a little more space down here. And let's talk about row echelon form. So how do I know if it's in row echelon form? Well, you have to satisfy these following conditions. Number 1, rows consisting entirely of zeros. If there are any. Occur at the bottom of the matrix. Number 2, the first entry in any row with non-zero entries is 1. And number 3, the column subscript of the leading 1 entries increases as the row subscript increases. So, and let's look at what that last part means, because that seems a little weird. So here is an example of a matrix in row echelon form. So this is an augmented matrix. And what this last part means, column subscript. So like column 1, row 1, column 2, row 2. What that basically means is that the leading ones move to the right as we move down the rows. So row 1, column 1, row 2, column 2, row 3, column 3. So it's moving to the right and down. So this is an augmented matrix in row echelon form. It meets all 3 of those requirements that we just talked about. Okay, let's talk about operations that we can do on a matrix. Let's get a little more space. So we're going to talk about elementary row operations on a matrix. So these should seem familiar from talking about Gaussian elimination. So first thing that you can do is you can interchange any 2 rows. Next thing you can do, multiply all elements of a row by a non-zero real number. Not getting into those imaginary numbers with this yet. And number 3, add a multiple of 1 row to any other row. And these are basically the 3 things that we talked about we can do with Gaussian elimination. So let's look at an example on how to find row echelon form from an augmented matrix. So example. So let's say I tell you solve the system. And your system is x minus y plus 2z equals negative 3, 2x plus y minus z equals 0, negative x plus 2y minus 3z equals 7. Alright, so first thing we need to just turn this into an augmented matrix. Easy step. Just take each coefficient. 1, negative 1, 2, negative 3, 2, 1, negative 1, 0, negative 1, 2, negative 3, 7. So now our goal with this is to end up with zeros in these positions. And I want these positions to be a 1. So it looks like first equation is doing pretty good. Second row, or second equation, is close. I got to get rid of that 2, turn it into a 0, and I want to make sure I can keep 1 in that second column, second row position. And then the last one, I got to get rid of 2 coefficients and change that negative 3 into a 1. So let's think of things we can do. First thing I'm going to do is work with this second row and first row. So first thing I'm going to do is I'm going to multiply that first row by negative 2 and add it to the second row. So we can write that as negative 2 times row 1 plus row 2. So what do I get when I do this? When I multiply the first row by negative 2 and then add it to row 2 and replace row 2 with that, row 1 and 3 don't change. So my new row here in the middle is going to be, let's see, 0, 3, negative 5, 6. Cool, that's looking good with a 0 in that spot. Now let's see if I can get a 0 in this spot. Okay, so the next operation I want to do is I just want to add row 1 and row 3. Starting from this augmented matrix. So I'm not going to rewrite it because we can just look back over there. So row 1 plus row 3, and we are going to replace row 3 with it. So leave row 1 alone. 1, negative 1, 2, negative 3. Leave row 2 alone. 0, 3, negative 5, 6. And then add row 1 and row 3 and write it in place of row 3. So we're going to end up with 0, 1, negative 1, 4. Okay, I like this. I got zeros here and here. Now let's see if we can turn this one into a coefficient of 1. And actually what I'm going to do for this is I'm going to switch places with rows 2 and 3. Because if you see, row 3 has a 0 in the first spot and a 1 in the second spot. So I'm going to switch places with those because it'll be easier to do that than to turn this 3 into a 1. So we write that by saying R2, 3 That's not row 23, that's switching row 2 and 3 to get a new version of this matrix. So switch rows 2 and 3, and our matrix will look like this. 1, -1, 2, -3, 0, 1, -1, 4, 0, 3, -5, 6, just like that. So we switched rows 2 and 3. So I'm liking how this looks. Got zeros in the right places, and I've got D1s going down. So now I need to see if I can get rid of this 3 right here. So to do that, I'm going to multiply row 2 by -3 and then add that to row 3. So -3 times row 2 plus row 3. And the new matrix that gives us should look like 1, -1, 2, -3, 0, 1, -1, 4, 0, 0, -2, -6. Cool, we're getting ever closer to this row echelon form. Almost there. It looks like next thing I need to do is see if I can figure out something with this number right here. So I've got my 1, 1, and I need a 1 here. My zeros are all correct. So let's think, what can we do to turn a -2 into a 1? So the operation that I want to do to this, I want to multiply row 3 by -1/2. That'll be the easiest way to get there. So when I multiply row 3 by -1/2, rows 1 and 2 stay the same. And row 3 becomes 0, 0, 1, 3. And if I think about what we said for row echelon form, I've got zeros here, ones going down and over like that. So this looks like it is in row echelon form. So we are happy. So if I'm trying to solve this system of equations, my last step would be to take this row echelon form, turn it back into a system of equations, and use substitution to find my final solution. So I can say this is x minus y plus 2z equals -3. That's the first row. The second row says y minus z equals 4. And this third row says z equals 3. So I know z is 3, so I can just substitute one at a time. Start at the bottom, work my way up. Y minus 3 equals 4. So that tells me that y has to be 7. And then I can take this 7, plug it in here, plug my 3 in here, and I'll have x minus 7 plus 2 times 3 equals -3. So if I solve all of that all the way down, I get x equals -2. So then my ordered triplet for this goes x, comma, y, comma, z. So -2, y was 7, and z was 3. And there we go. That is the solution to this system of equations. Okay, I know this week's is getting a little bit longer, but there's one more thing we can do with these. So if we go back to this final augmented matrix, we can keep doing our row operations and end up with what we call the reduced row echelon form. We want to look at that real quick. It's going to be kind of cool and help us out. Okay, so if we look back to this final form that we had, it was 1, 0, 0, negative 1, 1, 0, 2, negative 1, 1, negative 3, 4, 3. So here's our augmented matrix. So now our goal with this one is to have our last part is going to have numbers. But then with this little 3 by 3 section over here, we want to have in each row and each column 1, 1, and the rest are zeros. So just like we have here, we want these to be 1s, and then we want these and these to be zeros. So we're going to see if we can figure out how to do that. And you'll see when we're done that this actually just gives us our solution pretty easily. So the first step that I'm going to do to get there is I'm going to do row 2 plus row 1. And I'm going to put it in place of row 1. So row 2 plus row 1. So when I add those two rows together, and I said I'm going to leave rows 2 and 3 as they are, row 3 is perfect. It's got the zeros and 1s exactly where we need it to be. It's row 2 and 3 that we need to change. So we're leaving rows 2 and 3 alone for now, and we're adding row 2 and row 1 and putting in place of row 1. So then we get 1, 0, 1, 1. Okay, we're closer to where we need to be. So the next thing I'm going to do to try and get this location right here turned into a 0 is I'm going to multiply row 3 by negative 1 and add it to row 1. And what do I get when I do that? Need a little bit more space. So when I do that, I end up with 1, 0, 0, negative 2. Great, this is finally in the form I want it to be in for that row. 0, 1, negative 1, 4, 0, 0, 1, 3. So looking at this, row 3, I don't want to mess with it. It's perfect. It's got my zeros where I need it. 1 here and then a number here. Row 1 has its 1 in the right place and the rest are zeros. And that number is where I need it. So I need to see what I can do with row 2 to have a 0 in this spot. So I'm trying to put a 0 in this spot. What could I do to put a 0 in that spot? Well, it looks to me like I should add row 2 and 3 together. So I'm going to say row 3 plus row 2. And you notice the last one is where I put the answer. So when I say row 3 plus row 2, that means I then replace it, row 2, with that. So what happens when I do row 3 plus row 2? I'm going to get a matrix that looks like this. Row 1 doesn't change. 1, 0, 0, negative 2. Row 3 does not need to change. 0, 0, 1, 3. And then row 2 turns into 0, 1, 0, 7. The reason why I want to go this far and get to this form is because now I can remember that this is x, y, z, and then the constant over here. So I can look at this and I can read my solution straight off of this matrix now. I see that x is equal to negative 2, y is equal to 7, and z is equal to 3. And if we remember what we wrote down for our solution, these are the same. So basically what I did with those last few row operations is the same thing as substituting would do. So the reduced row echelon form is real easy to read the answer and the solution to the systems off of. Let me know what questions you have this week, and I will see you on Zoom soon.